And here we are, the granddaddy of all quantum weirdness, the infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern! We fired... What? An interference pattern! What? Interference pattern! How could pieces of matter, it doesn't make sense, create an interference pattern? How? It doesn't make sense. They thought physicists are clever. How? So, they decide to shoot physics. They could interfere with each other. Maybe those little balls are bouncing off each other and creating that pattern. But after an hour of this, the same interference pattern. The conclusion is inescapable. All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So, they decide to shoot an interference pattern. But the quantum world is far more mysterious than they could have imagined. When they observed the granddaddy double slit, there is an interference pattern. Let's go to the other side of the universe. But the great-great-granddaddy of wacky quantum weirdness is entangled. Little balls look at waves. And what does an observer have to do with any of this? All of these possibilities are in superposition with each other. But physicists were completely baffled by this. They put a measuring device by one side. The conclusion is inescapable. When they observe, so they decide to shoot physicists. What? 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 And it was here that physicists stepped forever into the strange netherworld of quantum events. What is matter? Or waves? And waves of what? And what does an observer have to do with any of this?